Today we will be moving away from traditional layouts like HStack and VStack, and will in turn create our own layouts to distribute guests around the table. Let's begin by looking at what has been added to the app. We have the normal reservation list. There's a button to add a reservation, and here's what changed. We have a new section with the table. Here it's just a representation of the table, a visual, and we add guests. So as we keep adding guests, the number increases. For now we have 4. After that it changes to a circular table, but we're not showing the guests. What we want to is that the guests are distributed around the circular table. And let's see also how the implementation is done for this rectangular table with up to 4 guests. Okay, here we have the reservation view. It's just a new section. We added a button to the header to hide and show the table. And inside we have our new view, the guest table view. So inside we can see that the implementation for the guest placement is not that elegant. First we have a different background. So we have a rectangular table when we have up to 4 guests. When the number of guests goes above 4, we change to a circle. Nothing new there, nothing fancy. Now, what is not very good is the implementation of the layer of the 4 guests. Why? Because, well, to distribute them horizontally, we use an HStack. To distribute the 2 rows, we use a VStack that embeds these 2 HStacks. And basically, we're coloring the guest with the number. And that's not good. I would not want this code in my real app. Also, this does not scale, as we will have to add a new condition and a new HStack and more spacers and consider the combination of those as the number of guests increases. Here we can not support more than 4. So let's change this. If VStack and HStack are not enough, let's create our own layout. So let's start with our own layout that will distribute up to 4 guests in the edges of the rectangle. How do we do this? We create a new layout. Let's call it rectangular layout. And it conforms to the layout protocol. As soon as we conform to the protocol, we get an error because we're not adding the necessary protocol stubs. So let's do that. We have 2. One is size that fits, where we control the size of the subviews inside of the layout. We are not going to deal with this on this video. So what we return is proposal and replacing unspecified dimensions. And that's it. So we're whatever the views size wants to be in our layout, we're going to allow them to be the size, which in this case is these circles that are a percentage of the width of the container. And that's fine with us. Where we're going to do all of our work will be in this place subviews. Here's where we're going to determine the placement of this. And so we can see how this is done, how our views are being placed. For now, we're going to try with 2. We will do that with our layout already in play. So instead of our geometry reader, instead of an HStack and VStack, we will have our own layout. So that's rectangular layout. And it works just as a VStack or HStack, where we add the brackets and inside we add our views. So it's going to be from 0 to the number of adults.
Let's remove the VStack.
And for now, everything is placed in the center. Now let's start here with the placement. So we don't need to return anything here. The only thing that we need to do is in this subviews array, we need to place them if we want to. If not, well, they will all be placed in the center, but that's not what we want. Let's calculate the, also we need to know the index. Since the odd the even views will be placed on the left, the odd views will be placed on the right. So for that we need the enumerated, and we will have here a tuple, so the index and the view. So let's start with the x offset. So the x offset, if it is even, they will stay on the left. On the right, it will mean that it will travel the bounds, the width of the bounds. We'll use the modulo function for that. So if it is even, nothing happens, and what we'll do is travel the width of the bounds. And for the y offset, we will use the index, and the index above 1 will go below. Keep in mind that this rectangular layout will only support up to 4 views. We'll play around with this later, but for now, just so the x coordinate will be, we start at bounds.minx. Keep in mind, this was mentioned in the WWDC conference, but it's very important. We should never assume that the origin is 0, 0. Instead, ask for the min x of the bounds. And this needs to be a cg float. So we'll add the x offset, and same for the y coordinate. Again, not 0, 0, but min y. And now that we have our point, we need to place the view. So this view has a method, place at. The point will be our x coordinate, the y coordinate, and the proposal is the proposed view size that we could have meddled with in this size that fits, but we're not going to do it. So we will just pass in the proposal that was passed in the parameters. Now, there are views here, it's just that notice that this one was here, so if we are adding the bounds and the size width, our other circle is around here. So this is actually not bounds.width, that's too much. Let's try getting, oh yeah, by the way, we don't have the size of the view. We can't get that. So let's get the view size from the view. So it's size that fits, again, the proposal. And we'll subtract the view size, that width from this. There's our other view. Let's increase the number to 4. There we have it. And once again, we're adding too much offset, so it's the bounds height. Now, where do we want our guests? Do we want them at the corner? No, we want them below. So let's center them. So for that, we will add to the min y the offset, but also, yeah, let's add half of the view size height. Okay, so the top row is done. We could also
move. Do you actually want to? I guessed. Yeah. So horizontally we have what we desire, and here we actually not want this. So let's. Yeah, we're subtracting half. Let's subtract. Much better. Maybe it's a little bit too much. Yeah.
Yeah, that's in total. Right. And there we have our placement. So we have our rectangular layout. Let's see it in action in our reservation form. So we have one, distribute here. The second one should appear here. Good. 4. Okay, there we have it. That's our rectangular layout. Now, what about 5 and above? We need to do our circular layout. Let's go back and create another layout. Create another layout that conforms to the protocol. Once again, we are not going to alter their size. So we will just return the proposal. And we're going to do something similar to this. Now, we want to start testing this out. So let's add 5. And instead of our rectangular, let's try our circular layout here. We'll have a typo here, circular layout. So we are in a circle. We're dealing now with other types of coordinates other than just dividing and multiplying. Let's start with the radius. So the radius in a circle would be half of our bound's width. And since we're inside of a circle, to get the x and y coordinates, we will have an angle. So the angle is going to be 360 degrees. We're going all the way around the circle, divided by the subviews of count times the index. And now the x offset will be the cosine of this angle times the radius. Keep in mind that the type of our angle is int. That doesn't work. We need C float. And also keep in mind that this angle here is in degrees right now. Cosine takes radians. So for that, we multiply by pi and divide by 180. And we'll do exactly the same for the y offset with the sine function. Let's add it to our bounds and see what happens. This will not work. We'll see why in a second. All of the views are around here, very messy. One of the reasons is we're starting from min x, min y. This is in the upper left corner. With this method, to distribute around the circle, we need to start on the center of the circle. Let's start from the mid x, mid y. We still are not there. Now, one of these reasons is because we're actually not drawing ourselves above the circle. Why? Because in our body, the content, we're doing a padding and then we're doing the overlay. So actually we're not drawing ourselves above the content, but we also have a padding. Let's remove this. And let's also add it to the preview. So actually make it a little bit bigger. And we can now see the other view now. We're still a little bit offset. Let's see why. To see this clearer, let's remove the x offset and the y offset and see where the views are being placed. We're not in the center of the circle. Why? Because we're placing the view and the anchor point of the view that we're placing, this x and y coordinate, is the upper left, just as the origin here. To see our circle center, we need to first subtract half of the size of the view. And we don't have it right now. Let's copy our view size variable from the other layout and subtract half of the width and half of the height. And now our views are centered. So let's now add the offset. And now our views are distributed. Let's try with another number, 6, 7, 8. Now notice how this is always changing. This circle is always being constant. I actually want the top circle to never change, so there always starts a guest here, and then all of the other ones are evenly distributed. To do that, we need to subtract 90 degrees. Keep in mind that the angles go clockwise, so had I added 90 degrees, the one that always stays will be the one on the bottom. Let's test this. Okay, our layout is ready. This actually works with 4, but yeah, we don't want that kind of layout. It works better in a circle. So how can we maintain our rectangular layout for the square and then a circular one? SwiftUI has another tool for this, which is AnyLayout. So we want a rectangular layout when it's 4 or less guests, and when it's more than 4, we want our circular layout. But now we have any layout, so let's create a layout variable. And if the number of adults is bigger than 4, then we will use a circular layout. We need to use type ratio for this. So we'll have our circular layout. If we're not more than 4, we use our rectangular layout. And then now we have our layout variable, which is AnyLayout. We replace this. And there we have our distribution. Now we removed our padding, so our rectangular layout doesn't look that well. So let's add our guest to the edges of the table. Here they are inside. Much better. Now, a little bit of bonus here. The transition in between layouts can be animated. So to our layout, we will add an animation to if in, and the equatable value will be the number of adults, which is what we are changing. Let's see how this looks in the form. So let's open it. We have this here. We need to add a little bit of padding, of course. One, 2, 4, 5, and here we go. This is how it's animating. We can even add a little bit more padding. Let's add 40. There we have it. And that was all for today. Layout is a very powerful new protocol exposed by Apple that we can all use to stop avoiding hacks like some of us do, which is getting the width from the width and the height from geometry proxy, sending this upwards in the view hierarchy and trying to lay out the system. This runs against the layout engine and may cause very unexpected behaviors. Now with layout, we can control all of this, and with any layout, we can change between different custom layouts easily. Hope you liked the video. Bye!